Hello everyone. In this video we're going to be looking at an infinite fraction. This is going to be a new type of problem for two reasons. One, we haven't done a problem like this before as far as I remember. Correct me if I'm wrong. Two, the answer at the end I'm going to leave somewhat open-ended and I'd like you to speculate. Okay? Let's go ahead and get started. Now we have this infinite fraction that goes like 3 minus 2 divided by 3 minus 2 divided by 3 minus 2 ... so on and so forth. So there are basically infinitely many terms here and we're going to evaluate this. Now with fractions or expressions like these with infinitely many terms, we're pretty much looking for a pattern. And once we find a pattern, we can use that pattern to evaluate. For example, suppose you had the following. Something like this, right? Obviously, if you knew the shortcut to this, you could tell the answer right away. But let's just assume that you don't. So what would you do? Well, you would probably set this equal to x, the whole thing, right? The expression under the radical. And of course, I do have square root of 6 plus square root of 6, so on and so forth. But notice that this expression actually contains itself, which is interesting. So we can safely say that if the whole thing is called x, then this part here is also the same thing, which can be called x, right? So then we get something like this from here. The square root of 6 plus x equals x. And then what would you do to solve for x? This is a radical equation, but I want to solve for x. So I would square both sides. That would give me 6 plus x equals x squared. And then you would put everything on the same side. X squared minus x minus 6 equals 0. And from here, you would get the factoring x minus 3 times x plus 2 equals 0. And obviously from here you could safely say that x is either 3 or negative 2. It's obvious that this expression cannot be negative. Therefore, the only acceptable answer is x equals 3. And actually that happens to work, right? So you would do something like this. Or if you had a product, pretty much, you would do the same thing and you would get 6 as the answer, right? Because if this is 6 and that's 6, you would get the same thing. Okay, that makes sense, right? So that's pretty much what we are used to doing for these kinds of things. Of course, I'm not talking about a rigorous proof here. I'm kind of trying to keep it very loose because that's the fun part. Okay, so let's take a look at that expression from that perspective. What would you do using the same idea, right? Well, the whole thing here, let me rewrite it. So we have 3 minus 2 over 3 minus 2 over 3 minus 2 over ... So you would call the whole thing x, right? And then what would happen after that? You would see that, okay, this contains itself, so this is the same thing. So that means it's also x. So then from here I get an equation. Well, my equation is not as simple as that one, but we can still solve it. So we're going to get something like this. And obviously, in this case, x does not equal 0 for sure. We know that, right? The answer cannot be 0. X equals 0 doesn't satisfy this, obviously. So we can multiply everything by x. That's going to give me 3x minus 2 equals x squared. And if we put everything on the same side, then you will get something like this. X squared minus 3x plus 2 equals 0. And obviously, this is a factorable trinomial. So we can just go ahead and factor it as x minus 1 and x minus 2. And it's equal to 0. Great. So from here, you're getting two solutions. Unlike the other one kind of gave us a positive solution and a negative solution. Negative solution was definitely not legitimate. We couldn't use it because the expression was positive. But here, you do have two positive solutions. So what are you going to do with them, right? Well, one of them is x equals 1, and the other one is x equals 2. But our expression is that one. So let's go ahead and rewrite that. We have 3 minus 2 over 3 minus 2 over 3 minus 2 over ... Now, we said that x is either 1 or 2, but the whole thing is called x. So how is that possible, right? How can one thing be two different values at the same time? That is the fun part of this problem. That's what I want you to speculate on in the comment section, okay? But let's go ahead and take a look at this problem from an answers perspective. So we said that the answer is either 1 or 2. So what happens if the answer is 1? Well, if the whole thing is 1, then it means that this part is supposed to be a 2, because 3 minus 2 equals 1. And that means the denominator is supposed to be 1. And that's kind of seems to be true. Why? Because if the denominator is 1, then the whole thing is the same thing as that, right? Pretty much. So then they're just equal. So I'm getting something like this. 3 minus 2 over 1 equals 1, which is true, obviously, right? So this seems to be true for x equals 1. So is that the solution? Let's check x equals 2. For x equals 2, I'm going to rewrite my expression one more time. 3 minus 2 over 3 minus 2 over 3 minus 2 over dot, dot, dot. So my claim is that this answer is equal to 2, right? Is that possible? Well, if that's 2, then the denominator is also supposed to be a 2, right? Well, let's see if that's true. Well, 2 divided by 2 equals 1. 3 minus 1 equals 2. So that seems to be true as well. So both of these answers seem to satisfy this equation, x equals 1 and x equals 2. So the million-dollar question is, which one is correct, or are they both correct? And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.